Have you ever wondered how we could go from a perfectly sunny day to powerful storms by evening? While there are many processes at play which power our atmosphere, one of the key drivers of our day-to-day weather is a process called adiabatic cooling and expansion. Adiabatic describes a process through which no heat enters or leaves the system in question, which for us is an air parcel. Imagine a ball of air with a certain temperature and pressure. We'll call this an air parcel. There are several different things that cause the air to rise: heating by the sun, being lifted by topography, like air moving up a mountain, through a weather front, or through convergence of air, where two air masses meet and one is forced to rise above the other. Let's say our air parcel starts at the ground, and there's a certain amount of force of all of the air above it pushing down on it, which is what we call pressure. But as that parcel starts to rise, it's experiencing less pressure because there's less air above it. And that means that the parcel is able to expand, sort of like relieving the pressure off of a stress ball. However, as the air parcel continues to expand, it pushes on the air surrounding the parcel because it has to sort of make room for itself. But in that process of pushing on the surrounding air, the air parcel will lose heat in a form of heat which we call sensible heat, and that will cause the air parcel to cool as it rises and expands. Once the air parcel cools enough, it will approach saturation, where relative humidity is 100%, meaning it can't hold more water vapor. Past this point, the water vapor in the air parcel will condense and a cloud will form. The condensation that occurs releases a different kind of heat called latent heat into the air parcel, which heats the air parcel and allows it to continue to rise. But the parcel will still be cooled as it rises and expands. This latent heat that's released through the condensation is the energy that will go on to power a thunderstorm if one forms. The air parcel will no longer continue to rise once its temperature is cooler than the surrounding air. However, there is a point in the atmosphere past which the air parcel is able to rise, and if it can reach this point, it will rise without needing to be forced up very quickly, and this is when we call the atmosphere unstable and a thunderstorm develops. To tie this back to our starting question, how can we get such devastating storms by evening after a beautiful day? Well, land heats up more and more over the course of the day, heating the air just above it, so air parcels are able to rise higher and higher because they get hotter, which can lead to massive storms by evening. So if ever there is a summer day and you start to see those puffy cumulus clouds by late morning, stay tuned for what might happen next.